Welcome back to this machine learning playlist. In this day 32 learning, we are going to be starting off with Ensemble Learning. It involves voting, bagging, pasting, and few other concepts. So let's understand Ensemble in a very simple and easy way. So we have looked at many different machine learning models. So with Ensemble, we use all of the machine learning models and take hard or soft voting to get the final result. Like, let's say we have five different predictors which predict a class of either cat or dog. We get this result with those individual uh, predictors, and we see cat being the highest voted one, so we say it's cat. So this is one of the examples of hard voting, but we will understand what is hard voting also. So there will be several predictors instead of relying on one. So that's the key concept here. Diversity is the key idea in Ensemble. Every predictor can make mistake, but collective result can bring out the accuracy. Hard voting is part of classification, either binary or multi-class classification. Ensemble class receiving the most votes will be selected. For example, here let's say 1 is being selected highest number of times, so 1 would be the output. So in case of soft voting, it is about probability. So the highest average probability would give out a reasonable result. So in case of soft voting, it is about probability, like percentages or numbers kind of things, and even having to put them in an entrophic or a Gini kind of representation would also help soft voting. So that's one thing. Okay, so we have Moon's data set here, and we have three different predictors, and we are having to predict these values. So that's one thing. So hard voting on the other end, you have voting classifier as a method, and voting is equals to hard would create uh, hard voting method. On the other hand, you would have voting is equals to soft, as you see here, that would create soft voting pattern. Okay. Uh, Next is why predictor diversity matters. Let's say we have 10 different classifiers with the same model, each of them say make the same mistake, then it is of no use. So let's say we have different algorithms, different hyperparameters, different subsets, and different feature subsets, and random seeds, and many variations, then it would be helpful. That's one of the reasons that random forest is also one of the popular models. So now come talking about creating different subsets or training sets, we have bootstrap sampling where we would be able to have bagging and pasting methods introduced. So in case of bootstrap sampling, we either can have same data set with jumbled data, or uh, uh, a data with some replacement in it or some randomness to it. As you see here, C is completely avoided with B being two times and A seen somewhere around the fourth occurrence or so. So that's bootstrap. That's bootstrap bagging technique. So here it's with replacement from the original data and randomness with the sample. Predictions are aggregated. Pasting technique, on the other hand, we would be taking small samples of the training data, like for example A or ABC or ABD or something like that, right? So there would be randomness with the subset input. So that's one thing with bagging and pasting to know. We can have bagging and pasting done something like this. If bootstrap is equals to false, it means pasting, like the way that we see here. If bootstrap is equals to true, it's uh, bagging technique. So that's one other thing. Comparing decision tree bagging and pasting, we get these set of accuracies which we can see. So that was it for today's learning. Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.